Welcome. This video introduces the idea of BitFlags, which are kind of like enumerations, only a little trickier to use and in some ways more powerful. So the potential issue with enumerations is they are designed to pick between a set of discrete values. Will either be A, B, C, or D, and not some combination, which means that they don't work right if we want to have something like font style that could be plain, bold, italic, or underline, and I want to be able to combine those to say like, well, I've got bold and italics. All right, so if I try and do that with an enumeration, I add up bold plus italics and cast that back to font style so I can store that as the current style. And then I check if it's bold, I print bold. If it's italic, print italic. If it's underline, print underline. And what I get is underline, which is kind of bizarre, but makes sense if you stop and think. In our enumeration, we've got 0, 1, 2, 3. Bold is 1, italics is 2, 1 plus 2 makes 3, underline. So BitFlags allow us to do things like this, to kind of have some enumerated types basically, but combine them in ways that make more sense. Now, they get their name from the fact that an integral data type is composed of a known number of bits. So for an int, if we're talking about PC, that's usually going to be 32 bits. Might be different for other platforms, but we'll assume it's 32 bits for right now. We can think of those 32 bits as 32 individual flags, or Boolean values, yes or no. 1 for yes, 0 for no. So bold might be the first rightmost digit. 1 indicates yes, we have bold. The next might be 0. This bit represents whether we're italicized. 0 is no. And then yes, we're underlined. And we still have 29 other possible values we could represent. All right, so we have 32 independent variables all stuffed into this one number. Now to make this work, to make sure we're actually setting values that are on those bit locations, we have to stop and think and realize that those are all going to be powers of 2. So if we want to set up kind of our options, we have to make sure that bold is 1, then italics is 2, underlines 4, all caps is 8. We keep working with powers of 2. The next one subscript is OX10. The OX says this is hexadecimal. 10 in hex means 16. So that's this bit. And then OX20 means 20 hex or 32, which is that bit. So by using the scheme, if I try and add up bold and italics, I get 1 plus 2 is 3. That's not going to become 4, and I'm never going to bump into other combinations by adding up 2 of those. Now, we won't actually add the values ever. First of all, once we start adding these, if I get something like 3, it's no longer a valid possibility, so I can't store what I get by adding these as a font style. I either have to store it as just an int, unsigned int in this case, to make sure I don't end up with a negative value by using large numbers if this enumeration keeps going, or maybe do a type def to create something called font style that I use. But we won't add things like bold and italic. Instead, we'll combine them using this operator. So this operator is the bitwise OR. It says, look at the two numbers and go bit by bit, and if either one has a 1, keep the 1. So 1 and 0 is a 1. 1 and 1, that makes 1. 0 and 0, no one's got a 1, so that's a 0. 0 and 0 is 0. We can also do bitwise AND with the ampersand. Right, this is different than the logical AND, which has 2, just like logical OR has 2 bars. Bitwise has 1. So you got to be careful if you've ever done that and you've typed 1 ampersand or 1 bar. You've probably gotten weird errors, and this is why. So bitwise AND says we have to have 1s in both numbers. So 1 and 0 makes 0. They're not both 1s. 1 and 1 makes 1. And then the zeros end up as 0. The hat symbol means bitwise XOR. If you've tried to use this for doing exponent, you've gotten weird results because you're actually combining two numbers bitwise with exclusive OR. If 1 but not both are 1, so like 1 and 0, that's a 1. If they're both 1s or they're both 0s, that's a 0. So basically we're making sure that only one of them has the flag set. And not, the tilde is bitwise not. It just inverts all the bits in a value. So we can use these logical bitwise logic building blocks to do things like, hey, combine bold and italics, because 1 or 1 0 are going to be 1 1. And then if I take that style and OR it with italics again, I've got 1 1 or 1 0. Well, I'm going to keep the 1, going to keep 1 because we've got both of them. Basically, it's like adding them together, but I'm never going to keep duplicate copies. I'm not going to add these two up and like carry into the next column, which would mess things up. And that's why we use these bitwise logic operators instead of normal addition. To see if I've got the same value, I can use AND. So if my current style and bold is equivalent to saying, hey, 1 1 and 0 0 0 1, do they have anything in common that are both 1? And yes, they do that last bit. So this has a value that's not 0, which would be true. So I'd identify that as bold. Same with italics. If I ANDed these two, I get that, which isn't 0, so I know it's italicized. If I combine these two with bitwise AND, 1 1 and 0 1 0 0, they have nothing where they both have a 1, so that'd be zeros, which is logical false, which means I know it's not underlined. I can AND with not something to remove a flag. If I want to get rid of bold, this would strike that bit flag off. If I want to reverse a flag, change it from true to false or false to true, I can use the logical XOR and do it with either bold or italics to reverse just one flag. Now, you don't have to become a master at these. You can always look them up if you need to. But it is important to kind of recognize them when you see them, because you will see them. Here's a sample from C++.com, the reference webpage that I list on my website. If you go look at the function input file stream open, if you want to open a file and set it to read binary data instead of text data, the way you do that is by doing something like this. Open my picture and set the mode we're reading from to be a combination of we're reading in the file, and make sure we're in binary mode. So combine those two using the bitwise OR to get the particular setting we're going to use for reading the file.